Hey there and welcome to the Code Wrinkles channel. By the time I record this video, .NET 7 has been released 1 week ago. And of course, the entire .NET ecosystem actually is very hyped about the new release, and everybody's talking about how great it is and what powerful things we can find in the new .NET 7. Now, as I'm always very transparent and sincere with you, I think that the .NET 7 release is not really spectacular, but it has some very important and useful features that I personally waited a long time to have them. So in this video, I will walk you through what I think that are the most useful .NET 7 features. And stay tuned because we will dive right into it. The first very important feature, from my point of view at least, in .NET 7 is the rate limiting middleware. And before we get into it, let me briefly explain why I think that this feature is really important. Like, most of us probably work on small or even mid-sized projects or maybe API projects that usually actually work on a single instance or that you host or deploy on a single instance. So basically, when clients make a request to that API, it is always made to that specific server. Now, until now, if you wanted to implement some rate limiting on that, it was kind of like a little bit cumbersome because you needed either an API gateway or you would need to write your own middleware to kind of like implement some rate limiting concepts directly in your application. However, this has changed with .NET 7 as we have now this feature by default in ASP.NET Core and we can use it directly here. And let me show you how this works. So first of all, what we need to do is, of course, we need to add our rate limiter as a service and to actually specify some options. And let me paste some code here and let me walk you through it. So first of all, of course, we have this add rate limiter method that we have on the services service collection. And here, of course, we can then just specify the policy name, because actually what you can do, you can even use several different rate limiting policies, and maybe you apply some of them to some controllers or on some actions, and other of them you can apply to other controllers or other actions. You can even implement rate limiting policies then globally and then separately use other policies locally on controllers or on action. However, in this video, I will not dive too deep into the very specifics, but if you would like to have a dedicated video to this topic of rate limiting middleware in .NET 7, just leave a comment below and I will be more than happy to actually create such a content if I see that there is really a need for it. Okay, now what I do here, of course, I specify a policy name, and then we have here several options. Now, one important thing is that we see here in these options, so it has rate limiting options. This is actually my abbreviation. And here we have this add fixed window limiter. Now, the reason why I use this is because it actually, in .NET 7, we have by default 4 different algorithms that help us to rate limit. Now, the first one, and probably also the easiest to get started with, is this fixed window limiter. Now, the concept of this fixed window limiter is that you specify a window of time and you specify a number of requests that is allowed in that specific time frame for a specific client that makes requests. There are also other algorithms, as said, like sliding window limiter, which kind of like is a little bit similar to this one, in the fact that we specify a time window, but that window is actually then subdivided in different segments, and then you have the limiting options per each segment and what happens with the segments or with the limits that were actually not consumed from for a certain segment. They may get to the next segment, but only in different conditions. Actually, it's very complicated to be honest, that sliding window limiter, but there is also this possibility that kind of like is a little bit more complex to probably service some very specific scenario. Now, there is also a third option, which is the token bucket limiter, which is very similar to the sliding window limiter, except that instead of using requests that you actually have to limit, you then just get some tokens for each window of time or for each segment of the time window. And then there is a fourth option, which is the concurrency limiter, which is not based on a time window or on a time frame, or a period, it's actually based on concurrent requests and how many concurrent requests are clients able to perform. Now, from all these type of rate limiters, I have actually chosen this one because I guess it's the most easiest and straightforward to get started with. And in this fixed window limiter, we have to specify some options. So the first one is this permit limit, which actually defines, okay, how many requests can we actually make in that specified window? And then the very next thing, we specify the window. And here we can use a time span from seconds. So we specify that in 12 seconds or during a window of 12 seconds, clients are allowed to perform a maximum of 2 requests. Then, of course, those requests go in a queue, and we have to specify some information or some options for the queue processing order. In this case, we want to process the oldest first also, and the queue limit, because we can set also a limit on the queue, is 2. The idea of the queue limit is that if you have requests and they are queued and they are waiting, or .NET waits until actually a new window opens and you have some new requests, and then actually it will service them. And we'll see just in a few seconds in Postman directly how it works. But that's actually everything for the options that we have set here for this limiter. Now, the next thing, as this feature is called rate limiting middleware, of course, we need to add a middleware for that. So we say here app use rate limiter, and that should actually do it. However, we are not totally ready, because what we need to do right now is go on the controller, and actually here on this method where we get the weather forecast, it's exactly the same template that we have in ASP.NET Core or in .NET 7. And here I want to say enable rate limiting. So it's an attribute, and here we have to specify in the constructor of this attribute the name of the policy that we have defined earlier. And let me check again, because I think that this policy is named fixed. So yeah, this name should be okay. Let me then double check. Okay, fixed, so it should work. Cool. Now, what we can do is I can run the application directly. So let me run that. And let me also go to Postman, because I have already prepared a request here so that we can run it. So let me just send the request. And we said that request is sending. Okay, could not get the request. Sending request again. And here we got a 200 okay this time. So it should be fine. Now let me check again. One request, one other request. And you see that probably I have already sent more requests in 12 seconds. Once again, 2 requests. And once again, I have exhausted my limited. So Postman is waiting and waiting and waiting until a next window actually opens, and I have a new fresh 2 requests that I can make in that window. So once again, it's the same thing. So you see, this is rate limiting in action and how it works in ASP.NET Core. Let me just close this and continue to show error message. No, I had a problem here apparently, but I don't really care that much anymore. So yeah, basically that's the whole thing about the rate limiting middleware and how it works and how easy it is to actually use them. And I really find this new feature in .NET 7 awesome. And I will probably totally use it for the different customers that I work with. Now, before we go into the second very important feature that I would like to present you, I would just like to have a kind reminder that if you didn't subscribe to this channel, and if you think that this content is valuable for you and that you like it, please subscribe, hit the thumbs up button, also hit the notification bell so that you are notified always when we have here some new content on the Code Wriggles channel. This being said, let's move on to the next feature that I think is very, very important. The second very important feature from my point of view, or at least a very interesting one that I think that I will use a lot, is the IParsable interface and the option to actually create your own types that are easily bindable, let's say, for instance, from your queries or from your body, so you can bind directly to your custom objects. And that's actually very, very nice. Let me show you what this actually means. And I would like to create here a class. So let me add, and I would like to have a new class here, and let's call this class date range. Let's maybe also type it correctly. Date range should be okay. So it's a public class. And the idea is that this class can implement IParsable of T-self, which is actually date range in this case, because this is what we want to be able to parse to. And of course, this kind of like actually makes us implement two methods, the parse and the try parse method, where the try parse is actually very, very important. Now, what I have done here, I have pasted some code that I have prepared already. In this case, this is a date range. It's a very, very simple data structure of mine in which I want to have a date only from and a date only to. So this is what for me actually means a date range. Now, for the parse method, I actually have implemented, or basically I try to parse using the implementation of the try parse. And if I cannot parse, I, well, just throw an argument exception, and otherwise we just return the result. Now comes the implementation of this try parse. Now, this try parse by default will get actually as parameters the string value that you actually want to bind from. You get the iFormat provider, which gets injected from ASP.NET Core directly. And of course, you have this out date range, because this is what you actually want to create, like bind some string to your custom data type, which is the date range. Now here, this code really is not that important. We just, well, split the string. We use the string split options operator to make sure that we remove any unneeded stuff from our strings. And then what we can do is simply use this date only try parse and the date only try parse for the first element in the array and for the second element in the array, using the provider that is already here. And then we outvar from date and the to date. And then we create a new date range from this, and we return true, because in try parse, this is what we need to do. We need to return true, and we need to put our new date range in this out variable. And if, well, we cannot do this actually, so if this string.length is not equals to, so it means that basically we don't really have a from and a to. In this case, we just return a date range with the default values for the from and for the to, and of course we return false in this case. As this is a try parse, we are not allowed to throw exceptions here. So that's a common rule that's very, very important to actually obey. Cool. So this is the whole idea, but I guess you get the point. The thing is, you can get here basically the string value, like the value of the string, and you can split the string and look for whatever you actually need in that specific string. In my case, I just wanted to look for some dates or for some strings that I could eventually parse to dates or to date only, and then just create a date range from them. But the idea is that you can really split the string however you want. You can do whatever you want with the string, implement your own logic that makes sense to actually extract the information from there. If there is something that could be bound to a custom data type of yours, then you can look for it and then bind it, or at least implement this actually try parse to actually find out how, or so that ASP.NET Core or .NET 7 finds out how to actually bind that. So that's actually what we need to do, just implement this IParsable of date range. And what this allows us to do is, if we go here in the weather forecast controller, actually, here I can do a very, very simple stuff. Now I have already prepared a request in Postman, and that request which is actually for a different route here. So we have the weather forecast controllers, or the weather forecast, which is okay. But then for the route, I have this by range. And you will see in Postman that I have already prepared that with a range variable. Now, the only other thing that I need to do, because here is where I want to bind. So the idea is that I want to take some information from the query string and bind it to my custom data type. So I'll say here, for instance, okay, let me check from query, and from this query I would like to see if .NET 7 can bind to a certain range, and that should be actually it. The only thing that I would like to do is just hit a breakpoint here and check or verify if actually this range is bound correctly. So let's run this application. So the API starts now, and just 1 second that everything is started. And then I will go right over to Postman, and here I'm looking for this get with IParsable. And as you can see here, I have the weather forecast, which is the controller route, and then I have this by range, and I have this query string, which is range, and I specify a date here that's of course in a string that is separated through comma or by comma from another date. And that's what I eventually would expect, that it would be bound to my date range custom data type. So I'm sending the request. As we can see, we already hit the breakpoint. And if I go here on this range, I can see that it's populated indeed with this date only. Like this is 24th July and this is 26th July. So everything seems to work because that's exactly what we have here in our query string. So 24 the 7th, 2012 and 26 the 7th. So everything should be okay right now. Cool. Then I can just actually stop this application right now because that's everything what I wanted to show you here. But I guess you get the idea. You can, for instance, use the query strings and use the information from the query strings to automatically bind to any custom data type of yours that makes sense just by implementing this IParsable of T-self interface that would kind of, or that would make you to implement the parse method and the try parse method, providing you the iFormat provider, and you can then out to an out variable which is of type date range, and this is how this binding will work. Cool. So this was the second very important feature. Now for the third feature that we will move to just in a few seconds, I would like actually to move away from the regular ASP.NET Core with controllers, and I would like to move towards the .NET 7 minimal APIs, because minimal APIs I think is something that is really great for the future. But at least in .NET 6 I was missing a very, very important feature that actually is enabled or that is present in .NET 7, and that's why I think it makes it the most important. So here we are in a very blank .NET 7 minimal API application, and I would like to actually dive directly into what I want to say. Guys, if you have followed my channel, you know that from my point of view, filters in ASP.NET Core are very, very important, because kind of it allows us to keep our code clean, because it allows us to move some or most of the cross-cutting concerns from the controllers in the different types of filters that we might have. And by the way, if you haven't watched it already, I have a video dedicated to what actually filters are and why they are useful on this channel. So I will leave the link to that video in the description below. If you want to check that out, then feel free to do that to find out more about filters and why I think that they are important. However, filters were totally missing in .NET 6 minimal APIs. And from my point of view, this is why the minimal APIs were a total no-go for me when it comes to, let's say, real scalable production-ready applications. So I would have still preferred, or I did still prefer, the standard .NET 6 controller approach. However, in .NET 7, we have kind of like filter support in the .NET 7 minimal APIs. However, the filters in .NET 7 minimal APIs are not quite that powerful like we know them in regular ASP.NET Core application, but still this is a very, very important point, and from my point of view, it makes the minimal APIs so much better. So let me just directly go into it and paste here some code. And we look together into this code. So what we do here is, first of all, we just specify here this color name. And that's just a string, a method that kind of like takes as input a string that represents a color, and it will then output a very simple message. And then what I have here in the minimal API is the map get. And then the route here for this map get is the color selector. And I have the color in the route as a parameter. And of course, we have this color name. So we take this in, it will be returned actually by this map get. However, the catch here is that we also have this add endpoint filter. And in this add endpoint filter, we see that we can use it or run it asynchronously. We get the invocation context and we get a next delegate. So very, very similar to what we have in regular filters. We have on this invocation context these get arguments, and since I know that my argument here color is actually the first real argument, I would already say get argument of string on 0, so the index 0, so it will be the first argument here. So I will get the color. Now I do here a very, very silly stuff, like if the color is red, well then bad luck, we just return a problem result because red is not allowed. We allow all other types of colors, but we really don't allow red. Now, of course, if we don't return the result, so if the color or the text here is anything else but red, what we do is we just await and pass in everything uh, to the next filter or in this pipeline, because you can concatenate several such filters. Like you can call add endpoint filter once, you can then call add endpoint filter once again. And like in regular ASP.NET Core filters, it means that before this endpoint is executed, this filter will be first executed. So this allows you to actually run some code before the routing delegate is executed, like this color selector and then the action. Then it allows you, if you write or if you put some code here after this await.next, you would then just not return it. And in that case, if you write code after it, it means that that code will be ran after this map get will be executed. So basically, you intercept that request on the way back, or the response, once it is created. So it's a very, very similar concept that we have also in regular filters in ASP.NET Core, that kind of like allows us to run some code before and after the execution of the action itself, which in our case is this very, very simple map get. And that's actually it. We have added a filter to a minimal API endpoint. Now, let me first run the application and see exactly what happens, because I have already prepared here in Postman a request for this. It will be get this minimal API filter. So let's run this with green. So you see, this is my argument actually that I have to provide. So if I click send, then the request is sending, and then we get this green. Now, if I replace this with red instead, which I know here is not allowed because I have defined it like this, I can click here send, and we see that, hey, we get the problem response. So yeah, the filter worked. And if we type the color red before anything was executed, or before the met get itself was executed, we actually got already this problem result with the information that red is not allowed. I know it's quite silly, but yeah, at least we have proved that filters work. However, there is one other thing that I wanted to show you regarding these filters or endpoint filters in ASP.NET Core, because of course it's kind of like a little bit messy to add your filters like this. Now, the idea is, of course, that you can add your custom classes that implement an interface that turns them actually into filters, and then everything is much more cleaner when you want to add a filter to a certain action or to a certain route. So let me get here and add a new class, and I will call this class color validation filter. And this color validation filter will implement the endpoint filter interface, and this interface will actually make us implement a method, and we'll implement interface, and that's virtually it. Now here, of course, we need to make our method async because we will await the next. And maybe let's just move this also on a different line so that everything is okay. Now, similar to what we had before, is that we get this endpoint filter invocation context, which is the context that we have used previously, and the next delegate. So the one that actually will pass in the processing of this to the next filter if there is any other filter in the pipeline. If not, then the delegate of the route will be executed and it will generate the response. Now, what I can do here is come back and take virtually all this logic that I have here and move it in my custom class. And instead of throwing a not implemented exception, I will then simply just paste the code that I had previously. Now, here we have to do some changes because here in this case, we call this context. So we change this to context. And when we pass it down the line, we also use this context name. So right now we have an endpoint filter. And if we go to program.cs, what we can do here is we can actually remove everything from here because we don't need it. And actually this add endpoint filter is also, or has also, a generic overload. And in this generic overload, I can say that I want a color validation filter. So this is what I actually want. And if I run the application, and if I go to Postman, I would expect actually the exact same result that we had also previously. So let me just execute it once again, waiting, and once again we got an error. So as expected, the filter worked. Let me prove this also with green, and let's check if the response is correct. Color specified green. So everything is correct, just as expected. So once again, what we have done is we have moved all the code that we actually had here. We have moved it in a custom class, which is our color validation filter. And in this validation filter, we have actually placed the logic that we have previously directly in program.cs. And this already made everything much more cleaner for us, which is okay. Cool. So that would be actually it for these minimal API filters in .NET 7. But before we wrap up this video, there is really one other very important feature that I really waited for and struggled without it for a longer time. And now I'm really happy and relieved that .NET 7 finally allows us or brings us something similar to this. So last but not least, here is the fourth feature that I think is very useful in the new .NET 7 release, and this is the generic math and the INumber interface. And you would probably say, hey, why is this so important? This doesn't really sound something to be very, very important, like generic math. Who does even need that? Now, I would like to give you a very practical example to also show you and showcase why I'm really excited actually about this new feature, maybe more than about all the other features that I have presented till now. And let me give you this very, very simple and concrete example. Let's say that I want to build a calculator class. Now, the problem is that when I want to build this calculator class, and if I want to calculate the sum, now the thing is that I would like maybe to, well, be able to actually do the sum for integers. Cool, I'll do that. But I would also like to do the sum for doubles. Oh, then I would have to do this once again. So actually I would have to create this sum method or overload for the sum method or just another sum method for each numeric data type that I would actually like to support in my calculator and that I would like to support with, well, calculating the sum. Now, of course, this is a little bit cumbersome because you would have to really write a lot of things. But if we go with a further example, and at a certain point, and if you're older here on this CodeWrinkles channel, you probably know that I ran a few live sessions on creating our own custom data types, and I wanted to create a vector as a custom data type. Now, the problem there was that when I was creating a vector, I would actually needed to overload the constructor to take in maybe integers, to take in doubles, to take in shorts and things like that. And that's actually even more complicated than that, because when I wanted to implement operations on vectors, then I would have to actually overload everything or create new methods for all the different data types that I might have. And using generics wouldn't really help in this case, because we cannot really define, for instance, or kind of like we cannot use the concept that is a number as a generic constraint. So this is actually the problems or the struggles that I personally dealt with a lot. And I'm sure that a lot of you in certain scenarios, or in a lot of scenarios actually, probably were thinking, hey, why can't I have a generic type constraint on numbers? Now, the cool thing is that you actually can have this type of constraint right now in .NET 7 due to this generic math and the INumber interface. So let me delete these two methods, and I have written already some code here, and I have created this very simple generic method that kind of like calculates a sum. So in this case, as you can see, is totally generic, like we return a t, we calculate the sum of t, then we take in a params of t, so we can specify how many numbers we want. And here we can set this type constraint that where t inherits from INumber of t. So this means that actually, as long as a data type implements the INumber interface, I can constrain that type, and then I can do specific operations that are for numbers. Because this INumber interface, if we go and take a look into it, it's a really, really huge one. It has a lot of methods that we need to implement for overloading operators. and actually doing a lot of stuff. There are also other sub interfaces that actually make us inherit or implement a lot of stuff. So it's really complex. Now, the good thing is that, of course, we don't really need to implement this INumber interface on our custom types. We can just use it to constrain the types that we might need in generic methods or classes to instances or to objects that are numbers. So we have the guarantee in that case that we can simply add the numbers, subtract the numbers, divide the numbers, and perform generally all arithmetical or mathematical operations that are supported on numbers. So this is actually very nice, because then I can go here and say, instead of this console write line, now I haven't created this calculator as static, and neither the methods, I think, no, they're public. So let me just create here an instance var calculator equals new calculator. Okay, and then what I can say here is console dot, if I also spell correctly, so console write line. And in this console write line, what I want to do is I can use the calculator dot sum. The thing is that I can provide here 1, I can provide here 1.1, and I can provide here, I don't know, 15 or something like this. And actually, as you can see, I have an integer, I have double, and I have another integer. And if I run the application, actually everything will run correctly. Now, you have to remember or to imagine that previously to this INumber interface, this was actually not possible, and it was a nightmare to actually work with that. But now, as I can use, or as we can use this INumber interface to actually use it as a generic type constraint, it brings us, or it opens to us, a totally new universe in which we can work with these objects that we are sure that are numbers. And this means that they also implement some operators and mathematical operations that are specific for numbers, and we don't have to create a lot of methods to really support each numeric data type with our different methods or classes that are actually based or that want to work just with numbers. So it's as simple as that. Now, behind the scenes here, there's actually, this is made possible by another feature. That's actually the fact that we can define in the interfaces static virtual methods, which was not possible anymore. And if you can see here, we say static virtual. And also in this interface, because it's an interface, and it's also that you can also provide an implementation, but that's a new feature that was added, I think, in C#9 probably. So it's not really new, the fact that you can actually provide implementation for certain methods, but this idea that you can make these methods on an interface or define these methods on an interface like static virtual is something new. And this is actually what enables us to overload, or basically to implement virtual operations like overloading operators and things like that. Before that, before this static virtual interfaces, this was not possible. So this is, for instance, also a good example in which this idea of static virtual methods on interfaces might be very helpful. But once again, from my point of view, or for me at least, from a very practical perspective, the most important part here is that I can use this INumber of t as a generic time constraint, and then have the guarantee that inside my method or my class, when I'm referring to t, I'm always referring to a number and everything that's possible to actually perform or to do with a certain number. Now, before I wrap up, I just want to also add that this feature is, let's say, not 100% new, as it was kind of like also present in .NET 6, but in .NET 6 it was more like an experimental feature, so it was not, it had the status of release candidate, so it was not really globally available. Like, you could use it if you want, but there was no real support or guarantee for that. Now in .NET 7 that changed totally, and now this INumber interface is a first class citizen of .NET 7, so you can safely use it wherever you want. And more than that, you can be sure that really all numeric types in .NET 7 actually implement right now this INumber interface. So this means that you can use it to type constrain your generic methods or classes to types that are only numbers, like integers, like doubles, like shorts, and so on and so forth. Cool. I think that this is it from my point of view. These are really the most important features or new features in .NET 7, although there are a lot of other improvements in the area of performance and a lot of different other stuff. But from my point of view and in a practical point of view, I think that I will also use these features as soon as I get to work on a real .NET 7 project because I think they are really, really useful. If you enjoyed this content, please don't be shy and hit the thumbs up button, subscribe to the channel if you didn't do this already. And if you do that, also make sure to hit the notification bell so that you are notified whenever we have a new content here on the channel. And last but not least, if you have to say anything, you have any questions, or if you just want to get a discussion going, head over to the comment section of this video and leave your comment there, and I would be more than happy to get discussion going with you. And last but not least, also, if you think that other people might find this content useful, don't be shy and share this content with them in your social networks, I don't know, at work, on forums, wherever you think that there might be people interested in this content, make sure to share them, and I think that they will be thankful to you. This being said, once again, thank you very, very much for tuning in, and until the next time, I wish you the very best.